value of our data. So last time we substitute x to theta. That's why we need to bring back the value of our x. So from theta we will find the value of x. Okay, let me copy this. Okay, me go here. So we say our answer from this integrand is that our answer is a to the 4 all over 8, then multiply by angle minus 1/4 sine 4 theta plus c, right? So need to bring back the value of x. So from here we have x. From x is equal to a sine theta. Let's solve for the value of theta. So we have x all over a is equal to sine theta. So our sine -1 x over a is equal to theta, right? So this is now our theta. So we have a to the 4 all over 8, and our value of theta is arc sine x over a. Then minus 1/4, and we have sine 4 theta. Sine 4 theta plus c. So we're in our sine 4 theta using from our trigonometry, the double angle. So from our trigonometry double angle, sine 2 theta is equal to 2 sine theta cosine theta, right? So if we have sine 4 theta, then this is equal to 2. Then since we have a double angle here, then we need a 2 theta there, right? If we have 2 theta there and we have theta, only theta here, and then if we have 4 theta here, we need 2 theta here. Okay, then we have cosine theta. So simply means sine 4 theta is equal to 2 sine 2 theta cosine 2 theta from our this from our trigonometry double angle formula. Double angle formula. Okay, so we have a to the 4 all over 8 sine -1 x over a minus 1/4, and our sine 4 theta is equal to this. So we have 2 sine 2 theta cosine 2 theta. Oops, sorry. Then our plus c, but if you take a look at our sine 2 theta, remember once again from my trigo, sine 2 theta is, our double angle is 2 sine theta cosine theta. It's just equal to 2 sine theta cosine theta, and our cosine 2 theta here is equal to cosine squared theta minus sine squared theta. So this is from our double angle formula from our trigonometry. So let us substitute the value of sine 2 theta and the cosine 2 theta. So what we have is sine -1 x all over a minus 1/4 times 2 times sine 2 theta is 2 sine theta cosine theta by cosine 2 theta is cosine squared theta minus sine squared theta. Okay, then 2 times 2 is 4, but 4 times 1/4 is just 1. So we have what we've left here is sine negative 1 x all over a minus the sine theta cosine theta multiply by cosine squared theta minus sine squared theta, right? Then plus c. Okay. Then how can we know the value of our sine theta? This one. So our sine theta is equal to x over a, right? So our sine theta, let's write this. Remember from last time that our sine theta is equal to x over a. Then how about our cosine theta? Where can we get our cosine theta? So our cosine theta is what's our cosine theta? This one. Maybe we can get our cosine theta here. So cosine theta is equal to divide both sides by a. So we have square root of a squared minus x squared all over a. So this is our cosine theta. So cosine theta is equal to square root of a squared minus x squared all over a. Okay, so from here we can now substitute the value of our sine and cosine theta. So we have a to the 4 all over 8 by sine negative 1x all over a minus our sine theta is x over a multiply by our cosine theta, which is square root of a squared minus x squared all over a, then multiply by cosine squared. So we have square root of a squared minus x squared all over a. So we have to square this cosine. So minus sine that is also being squared, wherein our sine is x over a squared, right? Plus c. Okay. So this is now our final answer. So therefore the integral of x squared square root of a squared minus x squared dx is this one, using the trigonometric substitution. Okay, what else? You can also simplify this. So let's simplify this further. So we have sine negative 1 x over a minus we have x square root of a squared minus x squared all over a squared multiply by square root of, we can cancel this out pala, square root squared is just a squared minus x squared all over a squared minus x squared all over a squared, then plus c. Further, we have sine negative 1 x over a minus x square root of a squared minus x squared all over a squared multiplied by a squared minus x squared, right? Plus c. So we have a to the 4 8 multiplied by arc sine x all over a minus multiply this one, we have all over a to the 4 and then x square root of a squared minus x squared by this is a squared minus 2x squared, right? Yan. Then our plus c. Can we further simplify this? Let's multiply both term by a to the 4. So we have a to the 4 all over 8 sine arc sine x over a minus a to the 4 all over 8 multiplied by x square root of a squared minus x squared by a squared minus 2x squared all over a to the 4 plus c. So we can see this, that we can further cancel this out, and finally we have a to the 4 sine negative 1 x over a minus x square root of a squared minus x squared by a squared minus 2x squared all over 8 then plus c. So this can also be our answer, or if you still want to factor out 1 over 8, then you may do so. So what we have left here is a to the 4 sine negative 1 x all over a minus x square root of a squared minus x squared by a squared minus 2x squared, then our plus c. Okay. So this is our one of the sample integrand using the trigonometric substitution.